we have discussed about specifying assertions. Okay, so we have seen that assertion language primer also. Okay, now we are going to discuss about how to write an assertions on internal DUT signals. Okay, okay. Assertions and coverage points on internal signals are inserted by designer during the detailed implementation of the block. This section contains some guidelines on typical areas in the design that should be instrumented with assertions. This list is not exhaustive as it is not possible to enumerate all design structures. Getting this one? So now we are going to discuss about how to write assertions in DUT. Okay, inside a DUT. So the person who implemented the design only knows how to and where to implement that assertions, right? Because the person who implemented that block only knows more about that block than others. So if he writes all those things, it will be better. Okay, so in this section in VMM recommended some guidelines to write those assertions on internal DUT signals. The basic rule is that any design code that embodies non-trivial behavior over time should be instrumented with assertions. So the things which are all very important in your design should have this kind of assertions. Okay, now we'll see the recommendations. The first recommendation is what internal assertions should be used instead of comments. First thing, that means what? Instead of writing comments, for example, an assertion with its failure messages, an assertion with its failure messages serves a form of documentation. An active comment that describes in both formal and natural language that expected behavior of signals involved in the assertion. If that behavior is not respected, the assertion fails and the failure reports the violation. Of course, not all comments can be turned into an assertion, but where practical, internal assertions will provide increased observability and immediate identification of structural design errors. Okay, so here the recommendation is internal assertion should be used instead of comments. Instead of simply writing comments, it is better to go with this assertion. Okay, so in assertion we know that pause block also is there and fail block is also there. So in pause block you can do some other operation based on this assertion failure or assertion pause, and you can display some useful messages. Okay, and the second recommendation is what? Internal corner cases should be identified using coverage properties or coverage group. In system verilog assertions we are having cover group keyword, right, to write functional coverage related things. Okay, so to ensure the completeness of verification should designers should identify all corner cases in the implementation using cover property statement or a cover group instead of specifying a test case for the verification team. What is that? Designers should identify all the corner cases in the implementation using cover property statement or a cover group instead of specifying test case for the verification team to write. So the designers normally will do the functional coverage, normally will implement the functional coverage by, so you can instantiate in a module or interface or program everything. It makes your life easier, right? And the next rule is every FSM shall have assertions that verify the state encoding and assertions, state transitions. So for example in OVL we have seen one not asserted, one not asserted, one cold, right? So you can use all those things here, especially while implementing FSM. Look at here. In in VMM standard checker library, what are all these assert bits, assert 1 cold, these are all well known. Okay, assert 0 1 hot, assert 1 not. These are all some other things which will support this FSM behavior checking. Okay, and then next rule, every internal block interface shall have assertions that verify assumed interface protocol. Getting this one? Every internal block interface shall have assertions that verify assumed interface protocol. For what they are trying to say here, unverified assumptions used in the implementation of an interface are often a source of errors. If the neighboring block violates this assumption, therefore each interface should have assertions on the complete protocol. Okay. Numerous standard VMM checkers can be used to build appropriate assertions for interface protocol. So in the interface protocol, what all things we can use? In the standard VMM checker library itself, we are having all these things related to this internal block interface. Now look at here: assert frame, assert handshake, assert time, window unchange. So these are all examples for that. Next, look at the recommendation 3.11. Interface related assertions or checkers should be specified in the interface declarator. We know that the interface in system verilog, right? So again, it is recommended practice to collate all those things inside the interface. Okay, look at here: interface name and module. See, it will have its own module. Inside the interface, we are declaring this assert property, and that too inside a switch. Look at that, if end of switch.